2, 1. Okay. So 1, 2, 3, go. Good day, everyone. We are the group 6, and our reporting is about the moments of statical stability. So before we begin, let's first know our learning objectives. So our objectives in this report will be define the moments of statical stability, recognize and demonstrate the triangle of Hill, apply the formula in solving angle of Hill, determine the formula in solving for the small angle and large angle, and lastly is to apply the formula to the different problems. So, moment of statical stability is defined as the moment to return the ship to the initial position when inclined by external force. So, let's now learn about the formula. Okay? Yes. The perpendicular distance between the line of action forces is what you call GZ and also called righting lever. The moment of statical stability is equal to the product of stability. The moment of statical stability is equal to the product of righting lever and the displacement. So that is why our formula is W times GZ.
Easy.
Yes. So what do you call the perpendicular distance? That we call the GZ.
Easy.
GC.
Or
Or
the
writing
righting lever.
lever.
Writing lever.
Okay, very good. Next slide.
Now, how to find the sine angle of Hill. We assume that a ship hills a given degree.
Yes.
A right triangle is formed. This is shown in the image in the right, where M is what we call the metacenter, GM is known as the metacentric height, and GC as the righting lever or arm. And since it forms a right triangle, a simple formula is used. Sine angle of Hill equals opposite over hypotenuse. From the formula SOHCAHTAA,
Yes.
which our GC is the
Righting lever or righting lever.
right, and our GM is what we call hypotenuse, right?
Yes.
Opposite over hypotenuse. So yeah, next. The moment of statical stability at a small angle of Hill. The metacenter is considered to exist for angles of Hill up to about 15 degrees. So only 15 degrees below. It is considered as the small angle of Hill, where theta is equal to angle of Hills, GC is our the righting lever, W is known as the ship's displacement, the sine angle of Hill, which is the GC over GM. And to find GZ, we need to multiply the GM times sine theta, or the sine angle of Hill. So proceed to our example problem. A ship of 4,000 tons displacement has a kg 5.5 meters and km 6 meters. Calculate the moment of statical stability when heeled 5 degrees. So we need to find the statical stability.
Yes.
In order to find the statical stability, you need to find the GM first, which is not in the given. So you need to use the km minus kg, which is 6 meters minus 5.5 meters, which is our GM is 0.5 meters.
0.5.
And now we can, now we can find the moment of statical stability. The formula displacement, or the W times GM times sine theta, or sine angle of Hill. So distribute the given 4,000 tons times 0.5 times sine theta, sine 5 degrees, and which gives our moment of statical stability equals
174.4 tons
per meter. Now, in order to proceed, let's have Luwaton Yusuf.
Okay ra na maputo kaya ako rin i-edit mo niya kung dili diyon ka storya ba. So, luwaton. There you go. Patol, basin ka off yung mic.
So formula for P. A close approximation for the metacentric radius or BM of a shape which is sometimes useful and can be found by the following formula. So where B is the shape's breadth and B is the Hermine draft and A is the coefficient. So what's the formula for BM? BM equals
AB squared
AB squared
Squared
over D.
over D. The moment of statical stability at a large angle of view. As shown in the image, where the ship is held to an angle of more than 15 degrees, the center of buoyancy has moved farther out to the low side, and the vertical zero B1 no longer passes through in the initial metacenter. So the moment of statical stability is equal to W, or the displacement
Basement.
times to GZ, which is the writing lever.
Yes.
But GZ is no longer equal to GN, sine angle of view, up to the angle at which the big edge is immersed.
Okay.
So now GZ is, or the writing lever is not equal to GN sine angle of heel, if we see in the illustration. To
Yes.
solve this, what formula we are going to use?
The
Wall-sided
Wall-sided
formula.
formula.
Right, wall-sided formula, which is GZ is equals to open parenthesis GM plus 1/2 times BM times tan squared angle of heel close parenthesis times sine angle of heel. So let's proceed to example number 1. A ship of 6,000 tons displacement has KB, which is 3 meters, KM, which is 6 meters, and KG, which is 5.5 meters. So to find the moment of statical stability at 25 degrees heel. So we know already that we are going to use the wall-sided formula. So to get the GM, let's subtract the KM, which is 6 meters, and the KG, which is 5.5 meters. So 6 minus 5.5 is equals to,
0.5.
that's right, 0.5. So 0.5 plus 1/2 times 3 times tan squared 25 degrees is equals to 0.8262. So to get the GZ, we should multiply the 0.8262 times sine 25 degrees. So our GZ is equals to 0.35.
0.35.
That's right. We are not done yet because we need to get the moment of statical stability at 25 degrees heel. So to get this, we should multiply the displacement times GZ. So 6,000 tons times 0.35 is equals to 2,100 tons per meter. So for calculation of BM for a ships, there are two formula. For a ship vessel, our formula is BM is equals to I, which is moment of inertia of the water plane, divided by B ship's volume of displacement. For the box ship vessel, our formula is BM is equals to B squared divided by 12D.
Apa sa oras?
So let's have here an example number 2. First is we need to calculate the displacement. So let's have here an example number 2. A box-shaped vessel 65 meter times 12 meter times 8 meter has kg 4 meter and is floating in salt water upright on an even keel at 4 meter draft FNA. Calculate the moments of statical stability at 5 degrees and 25 degrees heel. So first is we need to calculate the displacement, which has the formula of L times B times draft times the water density of salt water, which is 1.025. So the length is 65, the breadth is 12, and the draft is 4. Multiplied, and we will get the 3,120 tons. Then the answer will be multiplied to 1.025 salt water density, and we have a final displacement of
3,198 tons.
3,198 tons.
yes, 3,198 tons. Next calculation will be for Kibi with a formula of 1/2 times drop, or simply Kibi is the half of drop. So 1/2 times 4.0 meter, we will have a Kibi of how many meters?
2 meters.
2.0.
Yeah, that's right. Then, since we have a vessel of box shape, the calculation for BM has the formula of one no, has a formula of b squared divided by 12d. So we have a breadth of 12 meters, so 12 times 12 divided by the product of 12 times a drop of 4 meters, and the answer is 3.0 meter. Now, we will going to get the value of GM. The formula will be Km minus Kg. Since we already have a given Kg of 4.0 meter, we will going to find the value for Km. So to get, simply add the calculated Kb and Bm. So 2.0 meter plus 3.0 meter, we will get a km of 5.0 meter. Yeah, then we can now subtract 4.0 meter from the value of km, which is 5.0 meters. So our value for GM will be
1 meter.
1 meter.
1 meter.
1 meter. Yeah, that's right. Then to continue solving, I will give the floor to True Dustin Adriel.
Since we already have the value for our displacement, we can now solve for the GZ. The formula for GZ is GM times sine theta if the angle is less than 15 degrees heel. Since we need to find the moment of statical stability at 5 degrees, then we can use this formula. GC is equals to GM times sine theta, which is the Q or the degree angle. Our GM is 1 meter and the degree angle is 5. So 1 times sine 5 degrees is equal to 0.0872 meters. So we can now solve for the moments of statical stability. W times GC, so 3,198 tons times 0.0872 meters is equal to
278.9
278.9.
Tons
per
per meter.
per
That's right. So now in this example, it is required to have the moment of statical stability at 25 degrees heel. But before we can get the moments of statical stability, we should solve for the GZ. Since they have different degrees, then obviously GZ will be different. We should use the formula GZ is equal to open parenthesis GM plus 1/2 BM times tan squared theta close parenthesis sine theta. Our GM is 1.0, then the degree is 25 degrees. So tan 25 degrees is equal to 0.46631. Then sine 25 degrees is equal to 0.42262. 1/2 times 3.0 is equal to 1.5. So 0.6631 squared is equal to 0.21744. Then 1.5 times 0.21744 is equal to 0.32616.
16.
So 1 plus 0.32616 is equal to 1.32616.
1.3266.
Then when you multiply 1.32616 times 0.42262, the answer would be
0.505 meters.
then we have our GC. So we can now solve for the moments of statical stability at 25 degrees. So 3,198 tons times 0.5605 meters is equal to
1790.9 tons per
Per
meter.
meter.
that's right.
Okay. So that's all for our group 6 reporting. See, go get. Sakto ra gyud. Ay, kuan may
Next
kanang
mo na to.
mag-video tag kuan kanang ako nang i-edit diri dapit. So basin mapuno pa na ko ni dapita. So a little recap. So what is the formula of moment of statical stability? So we have
Displacement times writing
Displacement.
lever.
okay,
Yes.
that's correct. Well, for the angle less than 15 degrees, we have the
Sine
same.
angle of view
Pm times sine
equals
angle of hill.
Okay. While for the more than angle of here,
GZ is equals to open parenthesis GM plus 1/2 PM times tan squared sine angle of hill. Close parenthesis sine angle of hill.
okay, so those are the main formulas that are being used in the getting the moment of statical stability. Okay, mana? Oh, salamat kaninyo akong i-stop na.